So in this tutorial we're going to have a look at patterns in Solidworks. And what are patterns? Patterns are a way of creating copies of an original feature. So I've inserted some features that we're going to pattern onto this block here. You can see that we have a countersunk hole here that we're going to pattern. We have a little circular boss on the side of this block that we're also going to pattern. We have a slot shaped boss on the front here that we're going to pattern. A little hexagon shaped boss as well. And then on the back of this block we have a simple counterboard hole that we're also going to pattern. So these features that I've created on here, we're going to use each one in turn to illustrate a different kind of pattern feature that you can use within Solidworks. So all the pattern features are available in the Features tab, and the first one that we're going to look at is a simple linear pattern. So a simple linear pattern will allow you to copy a feature at regular intervals in a particular direction. So we're going to choose an edge of the block to define our direction. That's the first thing that we need to put in this first box, which is highlighted in blue. So the pattern direction for the first direction, direction 1, is going to be that edge, and you can see an indicator arrow to indicate which direction the feature will be patterned in. In our case that's correct because we want to pattern it along the block in this direction. If we pattern to the left, we will quickly run out of block to apply this whole feature to. But if you did need to flip the direction, you can just click on that arrow. So that's a common way of reversing directions in many different types of features. So the first thing I'm going to do is I'm going to skip direction 2, and I'm going to go all the way down here to features and faces, because I want to pick which feature it is that I want to pattern. So I'm going to pick features and faces entry box or selection box, and then I'm going to zoom in a little bit so it's easy for me to pick a face which was created by this whole feature. So either of these two faces will work. And when I select that, I get a preview of what the current pattern will look like when it's complete. Now you can see there's a problem here with this particular hole feature. If I patterned it now, the holes would kind of overlap with each other, and then they're kind of the bores of the holes would have a very thin wall between them. So let's adjust the spacing slightly. So if we put the spacing up to 20mm, for example, or 30mm, you can see the effect that that's having. And we can also adjust the number of instances in the pattern. So if we reduce that down to 4, it's worth noting that the system includes the original feature as instance number 1. So we have 4 instances in this pattern. We have the original, that's 1. First copy, that's number 2, number 3, and number 4. So it isn't 4 copies, 4 additional copies, it's 4 instances including the original feature itself. And if we just want to pattern in a single direction like that, we can accept that pattern feature, and you can see that the pattern feature now has been entered in at the bottom of the feature manager there. And if we need to go back in and edit it, as we're going to do in a second, we can do that. And the beauty of patterns is that all the other pattern members, so these are the 3 pattern members, are linked back to the setup of this original feature. So to illustrate that, if I go back into this whole feature that created the original hole and edit something about it, maybe I don't want an M8, I want an M6, which is slightly smaller obviously, then all the pattern members will update to follow the original setup of the original feature. So let's go back in and just adjust this linear pattern just to investigate what else we can make a linear pattern do. So as I said when I was setting this up, we weren't going to set up a direction number 2, but we are going to do that now. So I'm going to click on that option and select that entry box for pattern direction. Now you remember we used the edge as a direction reference for the first direction. Well, we don't have to use edges, we can also use planes. So I'm going to use the front plane in this instance. And what the system does, it interprets that to mean normal to the plane. So you can see the arrow for the second direction there. It's not along the plane, as in line or parallel with the plane. It's perpendicular to the plane or normal to the plane. I'm not seeing any previews of those pattern members, and that's because the instance number has been set to 1 by default. So I'm going to increase that a little bit and see what effect that has. So you can see other pattern members appearing now, and essentially what I've created is a grid here of pattern members. So let's adjust the spacing of these, maybe up that to 20, and let's just increase the instance count in that direction, and then press OK. So you can see the effect that we can get with linear pattern. We can pattern in 2 directions. In our case, we've picked 2 directions that are at 90 degrees to each other, but if we had an edge which kind of ran diagonal across the part, we could choose that as a directional reference, and we get, instead of a pattern that appeared kind of square or rectangular in its perimeter, it would be more like a parallelogram or even a rhombus. So that's linear pattern explained. The next type of pattern that we're going to look at is a circular pattern, and we're going to use this little boss extrude here to illustrate this. So the linear pattern is often the most common pattern that you will use. That's why it has its own icon in the features command manager here, but the other patterns are available in the drop down arrow below the linear pattern icon, so we can see all the other pattern types in this drop down menu. So we're going to select circular. Now the way that this is set up is it's prompting me to select the feature that I want to pattern first in this instance. So it's worth noting which one of these entry boxes is highlighted in this blue color, because that is the one that you're about to select something to put into. So I'm going to select this boss extrude. That gets put in the features to pattern. The direction in this instance is either a circular edge, a cylindrical face, or even an axis. So let's see if we can make the axes visible in here. So this part has some axes already in it, so we can select one of these axes to pattern around, or we can just click on a cylindrical face, which is what we're going to do now. So I'll turn the visibility of the axes off. So this cylindrical face will be fine for our purposes. And then we get a preview of what the current spacing and instance count will look like in this pattern. And if we want to adjust that, so we can see here that the angular distance, or the angle between each pattern member here, is 15 degrees. So if we wanted to increase that, we could type a new value in there, and the preview will update. So between each pattern member is an angle of 35 degrees now. We can also adjust the number of instances, or the number of members of the pattern, so we can see the effect that's having, and when we're happy we can accept that pattern, and then if we need to go back into the pattern and edit it, we just do it in the normal way. We just go into edit feature. The 2 main ways to set this pattern up are, you can give a spacing in degrees and a number of pattern members. So each pattern member in this instance will have 35 degrees between it and the previous pattern member. Or you can say the total number of degrees that the entire pattern covers and how many members there are in that pattern. So let's play with these settings slightly to see what's happening. So if I put the total number of instances to 10 and the entire pattern rotates around 360 degrees, then we know quite easily that the spacing is set to 36. So 36 degrees between each pattern member. adds up to 360. And we can use that for angles which are less than a full circle. So now we're going round a half circle here, 180 degrees. We still have 10 pattern members, so we know that the spacing now is going to be 18 degrees. So you can set this pattern up using either option. It's entirely up to you as to which one is most useful for your particular parts. So we'll accept that pattern and we'll move on to the next one. So next we're going to look at a pattern type called fill pattern. So this is quite useful if you need to fill all of the available space on a face of the part with copies of the original feature. So the first thing that this is asking for is a fill boundary, and if we hover over that box it tells us what is acceptable to select. We can have a sketch, it's got to be a closed sketch, a planar curve on a face, or a coplanar face. In our instance we're going to select a planar face, which is this flat face on the front, and then by mistake here I still had the previous circular pattern selected, so I'm gonna delete that out of that box. I don't want to pattern a pattern itself. What I want to pattern in this instance, so the feature I want to enter into this features to pattern box, is this little boss here. And when I select it I get a preview of what this pattern will achieve. So there's a few setup options that we can kind of change here. So I'm going to view this more kind of flat to the face. So there's a spacing option between the pattern members. If we reduce that we can see the effect. There's obviously a minimum spacing below which the pattern members start to overlap each other. And then there's an angular relationship between the rows in this pattern that we can adjust as well. So you can see the effect that is having. It's the kind of movement angle between one row, or one pattern member on one row, and the corresponding pattern member on the last row. We can also put margins on the face, just like margins on a Word document, where none of the pattern instances or pattern members will be allowed inside the margin. So if we wanted a 1mm margin around the edge of this part, none of these pattern members would go closer than 1mm to the edges of the part there. So that's the fill pattern. Quite useful often if you're having to model up things such as perforated grills or perforated metal or plastic parts, because you can do a cut extrude and then you can pattern it depending on how big or small the face becomes in the future. So that's fill pattern. The next pattern that we're going to look at is a curve driven pattern. So I've created a curve on this side face here just to illustrate how this pattern works. So the curve pattern will follow a sketch line essentially, or a chain of sketch lines. So I've created a sketch here for this purpose. I have a little boss feature at one end of the sketch. So this pattern's asking for the pattern direction first. In this case it's going to be the sketch that I've pre-prepared. Then it moves down to the which feature do I want to pattern box. So I'm going to select the feature that I'm patterning this time. Then I get a preview showing the current number of instances and the current spacing, and I can adjust that just as before, and you see the effect that that has. I can adjust the number of instances in the same way as before, or if I select equal spacing, what that does is it removes my ability to define the distance between each pattern member. It just asks me for the total number of pattern members that I require, and it spaces them along the entire curve itself, or the entire sketch line. So similar to the circular pattern in that respect. There's two ways of actually setting up the spacing. So now we'll move on to the last pattern type that we're going to look at in this tutorial. So this is the sketch driven pattern, similar to the curve driven pattern, only with the sketch driven pattern we can simply create a sketch that contains sketch points, which I've done here. So you can see the sketch points as these little asterisks. So this is a single sketch on this rear face of the part, and I've just used the point tool in the sketch toolbar and just place these points where I want one of the copies of the original feature to be. So this is quite adaptable as a type of pattern. It allows you, the user, to pick specifically where the copies will be. You don't have to follow a regular pattern or a regular spacing regime. So what is it asking for first? A reference sketch. I've already said I've created this reference sketch. Then again, I've made a similar mistake that I made last time, in that I didn't deselect this pattern that I made on the side, so it's used that as input, and you might make the same mistake, so it's worth showing that. If you have made that mistake, you can just right click and delete. What do I actually want to pattern this time? It's this little counterboard hole there, and you can see the effect that that sketch is having now. Wherever there's a point in the sketch, I get a pattern instance placed there. So that one's quite simple. Once you've got the sketch set up, you literally just have to select the sketch and the feature that you want to pattern, and then accept or cancel and adjust the sketch if you wish. So that's the main types of pattern that we can use within SolidWorks, and how they behave. If you want a copy of this block, I will upload a copy of the block without the patterns, so it will be like that, in that state, and you can kind of work through this tutorial as the tutorial video is playing.